Let's go ahead and get started. So just a little bit ago in the keynote, Anoop touched on some pain that developers have historically had when managing protocol buffers in a big system. In this talk, I, Richard, and Terry are going to give you a glimpse at a new GCP-specific registry we've been working on that will help you alleviate that pain and sort of supercharge your developer velocity when working with gRPC and with protocol buffers in general. So in this session, we're going to revisit what you heard in that keynote and then go into some more depth on the problems the registry will solve and how it all works. So this is sort of the 10,000-foot view of the registry. We believe this will become a core part of your development workflows over the coming months and years. There are some very real frictions in the developer flow for gRPC and protobuf today that the new registry will resolve. So I'll hand things over to Terry to outline some of those problems.
All right, thank you, Richard. So when managing the protobuf files of your system and the systems you depend on, there are generally 4 areas you need to think about. You have to think about in what repositories are the protobuf files stored in, how are the protobuf files shared across those repositories, and how you generate code from those protos. And also, if you're a library author, you have to consider distribution. How do you distribute the generated code? So let's look at some of the answers people have come up for storing the protos. If your organization uses a monorepo, you might be wondering what all the fuss is about. All your source code, including proto files for your project and all your dependent projects, is all in a single directory structure where you're free to refer to the protos and build them anywhere you choose. This is easy. But most organizations do not use a monorepo. And most likely, you are looking at a situation where your project and its dependencies are spread across multiple repositories. With multiple repositories, you need to decide where the proto files for your services live. They need to be available to both the server implementation and any client applications. A common approach is to store them in the server's repository. This works to a point. But what if you use 2 different implementations of the same service definition? Maybe your next-gen server is running alongside your old one as you migrate over. Or you use 2 vendors that implement the same service definition. Where is the source of truth for the service definition protobuf file? It's not so obvious anymore. Perhaps the most popular solution in recent years has been what's called a protobuf monorepo. Instead of taking on the burden of a full monorepo, you maintain a single repository just for your protobuf files. The challenge with this approach is to assure that your protobuf monorepo remains the source of truth. Your success there is dependent on your approach to sharing the proto files with repos that depend on them. Let's look at some ways that people have come up with to share protobuf files. If your build system supports it, you could have it download an archive of the remote repository with the protobuf files for you. Here you can see how you would do it with Bazel. It supports this. This, in a way, lets you simulate a monorepo by pulling down your external dependencies and merging them with your local repo. This is a possible approach, but can be fragile, and you might face some diamond dependency issues. You could also get more creative and write a custom shell script to download and compile remote protos for you. Maybe throw in some sed work to massage the generated code to work with your build system. It's not that elegant, but it's better than doing everything by hand. Or you could do everything by hand. You can copy and paste the protos from the other repository and check them in. Done. The obvious danger here is that over time, the protos can get out of sync. And you can even end up with over-the-wire incompatibilities that can lead to outages. I hope you haven't been there. If you're using Git, you have the option of using submodules. Submodules allow you to attach another repo as a subdirectory in your repo. There's a little bit of extra work in the Git CLI to keep your submodules updated, but overall, this can work fairly well. Now that you've found a home for your protos and you figured out a way to distribute them to all the other repos, you run into the next unusual aspect of protos. The proto compiler outputs more code to be compiled. This means that any build system supporting protos requires an extra layer of added complexity. The gRPC language teams have worked hard to provide language-specific build system plugins to generate both your message serialization, deserialization, and your stub and service code. But these plugins can be troublesome. They almost always depend on native code, proto-C implementation, which means that certain unsupported platforms are going to miss out. In addition, many languages have multiple supported build systems. If we don't have a plugin for one, the users have to fend for themselves. Also, sometimes people have off-the-wall combinations of language and build systems. For example, needing to generate Python gRPC code from within Gradle. This happens. All of this might lead to people to resort to shell scripts to generate their code. Here's one that's been spotted in the wild. But the worst situation is in many small projects where there's no integration with the build system at all. In these projects, you would generate code from the protos once and check the generated code into source control, possibly with hand edits to make it work for you. The next time you need to regenerate the code, you would have to go through the whole cycle again and hope that the person that has to do it next time does it right as well. After you've generated your code, you might be done. But if you're not just an application, but a library, you probably want to distribute the generated code as well as your proto source files. And you may want to share these artifacts between multiple dependent repositories. This can be difficult because to build code for a message B that contains a message A defined in a different repo, you need not only the full proto dependency source tree, but also the generated code for A or the generated artifact from it. If you don't have this, then the alternative would be to regenerate that code or artifact, and when you compile everything together, you could end up with duplicate symbols. You can use your language-specific packaging system with some established patterns on how to package protos and generate gRPC code. For example, with Java, you could build a jar file, and Python a wheel file. You can then use package manager to distribute. For example, Maven for Java or pip for Python. Now, you can, for example, distribute a client for your service that comes with nice documentation and handles tasks like input validation that you want to happen on the client side. Of course, if the users of your service are in multiple languages, you need to distribute a client for each of those languages, so you need different solutions. And for many, the process of generation and inclusion of protos into a library build is complicated enough for them to decide to just avoid it altogether. Too hard. Next, I'll let Richard discuss some ideas we have had to address some of these issues.
Great. Thank you, Derry. So that's a pretty good recap of the frictions that we have seen gRPC and protobuf users have over the years and up to the present moment. So let's turn to the solution that we have been working on. Given all of these issues, we realized that there was an amazing opportunity here to help our users. We wanted to build something that enabled dead simple reuse of popular public protos. Depending on other projects, protos shouldn't be rocket science. But today, depending on projects like the gRPC well-known protos or the XDS service mesh protos, is a super tricky task. And we also wanted to provide the same simple mechanism for private protos. After all, most gRPC usage today is within a single organization. Inter-service east-to-west traffic is super popular. So the registry will provide a source of truth not only for public protos, but also your organization's own protos. This will allow feature teams to stop worrying about protos and start worrying about their features. After your protos are uploaded, you want to be able to consume them in a language-specific way. In Java, you'll be able to add a Maven or Gradle dependency. In Python, a pip dependency. Depending on someone else's protos becomes as simple as depending on any other library in your language of choice. So it's well known that protobuf's strong backwards compatibility enables developers to confidently add new features to their protocols. But if developers unintentionally break wire protocol, you do not get that benefit. The registry will give you the confidence that you need that your organization doesn't break backwards compatibility. So let's return to the big picture diagram we started with. The registry aims to do everything I just mentioned and more. You'll be able to upload protocol buffer source code from your revision control system. The registry will help with enforcing backwards compatibility and buildability. You'll be able to depend on proto definitions from public projects, as well as other protobuf schema projects within your organization. So instead of feature teams having to figure out how to knit the entire organization's protocol buffers together, they can just focus on what matters, building out their protocols and integrating with the rest of the organization's system. The registry will let you use any source control system you'd like, Git, Perforce, Subversion, or absolutely anything else. And the registry will work no matter how you've structured your repositories. Any of the structures that Terry mentioned just a bit ago will work. So once you've uploaded your protos, the registry will parse and compile those protos, and it will generate and compile the language-specific artifacts you need to run your clients and servers, and also to serialize your protobuf messages. This will be powered by GCP Artifact Registry. And of course, we'll provide a standard gRPC reflection service to query all of this information programmatically, to drive developer workflows and any other piece of infrastructure in your organization that you would like to integrate with your schemas. So today, we're going to be opening up a private preview. We'll send out an interest form that you can sign up with to get access to that private preview. And that's going to include a read-only version of the Reflection API pre-populated with the most useful public protocol buffers, including the gRPC standard protos, the Google APIs protos, and the XDS service mesh protos. This will give you a taste of what the registry will offer over the coming months and years. We'll also be releasing the CLI tool that you'll use to interact with the registry. So at the moment, it will allow you to download textual proto source code to your file system. Now let's take a look at a couple of the interesting things that you'll be able to do just with this Reflection API that will be available to you very soon. So firstly, you can make requests to gRPC backends using this Reflection API. So with the new registry, you can do this even with backends that don't actually have a Reflection server enabled. The client, which could be a developer CLI tool or a UI, will make Reflection calls to the registry, and it will use that information to figure out how to convert your user input, which is probably JSON, to the serialized protocol buffer messages that the server expects. The registry will also enable a new form of REST to gRPC transcoding. The gRPC Gateway project is already used by many projects to serve REST incoming to their system, and then to turn it into gRPC within their system by transcoding from REST to gRPC. But gRPC Gateway takes a single proto at build time and generates proxy code for that one proto. And once you deploy that as an ingress proxy, you can't use any other APIs, just the one that you input. Now with this registry, a generic proxy can get access to up-to-date type information for any arbitrary gRPC API. This means that you can use a single ingress proxy for your entire organization, and that it will receive updates from the registry over time as additions are made to your API. Think of it as your API control plane. So let's run through a quick demo. And I have pre-recorded this just to avoid any unnecessary fat fingering and derailing. All right, so let's start by taking a look at some of the content that's pre-populated in the registry. How's our audio doing back there? Can we turn that audio up? All right, so let's start by taking a look at some of the content that's pre-populated in the registry. We have a new CLI tool here, currently called GCP Proto Registry. I don't have audio controls on my end. That's there. This will be your main entry point for interacting with the registry. So I've forwarded a port to this workstation from the registry service, and that is all right, let me talk over this a little bit. The registry contains repositories. Yeah. These are bundles of...
What about this guy?
Yeah.
He doesn't do anything.
No, unfortunately, no. Let me hop over to my other HDMI port. We had this working yesterday.
So for each request, we're going to save a key to help us identify that relative.
Take two. All right, so let's start by taking a look at some of the content that's pre-populated in the registry. Yeah. We have a new CLI tool here, currently called GCP Proto Registry. Yeah, so if we can't get that, I'll just talk over this a little bit. So we have a new CLI tool that we're introducing here. Name is TBD, currently called GCP Proto Registry. And this is going to be your main entry point for interacting. Repositories. These are bundles of proto files that may also
let me start this guy back over.
Repos. And there's a nice simple. All right, so let's start by taking a look at some of the content that's pre-populated in the registry. We have a new CLI tool here, currently called GCP Proto Registry. You can see the help text there. This will be your main entry point for interacting with the registry. So I've forwarded a port to this workstation from the registry service, and that is available on localhost at port 8443. The registry contains repositories. These are bundles of proto files that may also depend on proto files in other repos. And there's a nice simple mechanism for encoding that dependency. So let's take a look at the repos we've pre-populated so far. We have one big repository that just depends on all of our curated content. We call that the default repo because if you don't specify anything else, you'll get the latest revision of the default repo. So we'll take a look at the curated repositories by listing the default repo's dependencies. So to do that, we'll just use the dep command. So we've got three repositories here so far, just to give you a taste of the functionality. So we've got gRPC example protos. This contains our hello world example, our route guide example, and several other basic gRPC examples. We've got gRPC proto, which includes sort of the standard gRPC services that you would export from your server, such as channel Z, health checking, and of course reflection. And then we've got the protobuf well-known types, which are sort of the standard library for dealing with protobufs. So let's actually zoom in on gRPC example protos. We're gonna download the textual content of gRPC example protos to our file system. We want to give it the repository flag there. All right. So here you can see we've got a bunch of .proto files. Let's take a look at routeguide.proto. So this is the example that is included in a bunch of our getting started guides. It's sort of how we teach people the difference between unary and streaming RPCs, and this is written for all of our supported languages. So let's start taking a look at these types using the reflection API that the registry exports. So to do that, we're going to use gRPCurl. Like I mentioned, the registry is listening at port 8443. We're going to use the describe command, and we're going to take a look at the route guide package, route guide service, and we'll take a look at the get feature method. So same information we just saw in the actual .proto file, except we are doing this programmatically, and this can get incorporated into your developer workflows. Just to show you that there's nothing up my sleeves, let's go ahead and remove all of these .proto files here. Yeah, okay, they're gone, and let's do a different symbol this time. Let's look at the request message of the last thing, which in this case is going to be routeguide.point. And as you can see, we get the definition right there from the reflection service of the registry. All right, so now that we know that we can use reflection to get our type information, let's actually send an RPC. So the first thing we're going to want to do is to set up a backend that is running the route guide service. So to do that, we have got a server. I've got a Docker file here, very simple. We clone the gRPC Go repo, we build the route guide example server, and then the Docker container will run that. The other thing is gRPCurl does not actually currently give you the ability to point reflection at a different target from the backend. And so as most problems in, the same as most problems in computer science, we can solve this with one additional layer of indirection. And in this case, we'll be doing that with an Envoy proxy. So let's take a look at the configuration for that. In here, you can see we are splitting traffic. We are sending reflection requests to our registry backend, and we're sending everything else to our route guide I've taken these two things, Envoy and the route guide backend, and I've just orchestrated them with Docker Compose. Pretty simple. And let's just bring these components up. All right, these components are up. I'm going to come back over to this terminal. And now we're going to send a request with gRP curl. So this one's going to be plain text because the backend is listening over plain text. We're going to give it a request message. So we just use latitude and longitude here. I know there's a feature at 02, so we'll be using that. Longitude and 2. Now the Envoy is listening at port 10,000, so I'll use that. And then our method is going to be routeguide.routeguide/getFeature. All right. Boom. We have our response back. And so this is really powerful because it means that you now don't necessarily need to have a reflection server exported on your backends in order to use your really rich, familiar developer tools. This will open things up for old backends that do not have them installed, or if for whatever reason you're not able to install it.